This question asks us about the reaction between magnesium and dilute nitric acid, and first it wants an equation with state symbols. So magnesium, of course, is a metal, so it's just Mg. Nitric acid is one of those you must know is HNO3, and that's aqueous. Make sure you know nitric, sulfuric, common acids. And when they react, remember, metal plus acid goes to salt plus hydrogen. That's one of those basic recipes you need to know. So the salt will be magnesium nitrate. And make sure you don't guess. Stop and think about the charges on the ions. So magnesium is easy. It's in group 2, so it's going to form 2+ ions. Nitrate is one of those you're meant to know, is NO3-. If you're not absolutely sure, you can figure it out from the formula of the acid. Remember, that's H+, so you've got 1+, and therefore that must be 1- to make the charges balance. So one way or another, that's what you've got. And of course that means it's not just going to be MgNO3, because you need 2 nitrate ions to balance the 2+ on the magnesium. So it's MgNO3 twice, and that will be aqueous, and hydrogen, which is a gas. Then you've got to think about the balancing, which is easy because you can see you've got 2 nitrates there. So you think, okay, I'm going to need 2 nitrates there, and you check everything else and you find that's all you needed to do, that's balanced. Check you've got all the state symbols, which you have, and then you're ready to move on. So now the first calculation is based on the idea that we're adding excess magnesium, because it tells us that at the end some of the magnesium doesn't dissolve. So we have to work out how much magnesium is left. First thing to do is to work out how much nitric acid there was, because that is going to limit how much magnesium can react. So we start with moles of HNO3 is concentration times volume in dm cubed. And we've got the numbers for that in the question. The concentration is 3.00 moles per dm cubed, and the volume is 50 cm cubed. Don't forget to put it in dm cubed. Divide it by 1000, which is 0.05 dm cubed, and 3 times that is 0.150 moles of HNO3. So now we've got to think, okay, what does that mean in terms of magnesium? Well, the equation tells us, this is where these numbers in the equation come in, because the equation tells us that the moles of magnesium that can react is only half as many. So we can write down that moles of magnesium reacting is a half of the moles of HNO3. That's what the equation says. So we can just take a half of that number. Okay, 0.15 was the moles of nitric acid. If we halve that, we get 0.075 moles of magnesium. Now the point is, of course, that we added more than that. We added 0.1 moles, and that's why it's in excess. So what we have to do now is just simply to subtract the moles that reacted from the total moles, and that will tell us the moles that are left. So we get moles of magnesium left over is equal to the total moles minus the moles reacted. Okay, which is 0.100 minus 0.075, which is 0.025 moles left over. So now we're almost there, except we have to notice that it asked for a mass, not just moles. So always check that you've calculated what it actually asked for. So we've got to finally turn that into a mass. So we get mass of magnesium is moles times AR, because it's a metal. Okay, so that's 0.025 times 24.3, which comes out at 0.608 grams. And that's your answer. In part C, we're asked to calculate the volume of hydrogen that would have been produced in that reaction. So we've got to work that out from the moles of reactants. Now you've got to be careful, because remember, yes, we added 0.1 mole of magnesium at the beginning, but not all of that reacted, so you cannot work it out from there. You can work it out from the moles of magnesium that actually reacted, or most straightforwardly, you can simply work it out from the moles of nitric acid, because remember, we worked that out in the previous part, was 0.150 moles, and the equation says that the moles of hydrogen is half as many. So that would be the easiest way to start, by just writing that moles of hydrogen is a half of the moles of nitric acid, which is 0.0750 moles. So just make sure that you're clear why we couldn't use that 0.1, because not all of that reacted. So now we've got to calculate the volume. If it had said room temperature and pressure, we could have just done the 24 thing, but it doesn't. It gives us some specific values. So we've got to use the ideal gas equation, which you need to have learned. Okay, so we start with PV equals nRT, and we want to solve that for V, so we've got to rearrange it, and you should always write down the rearranged equation before you put numbers in it, not just for this but for everything. Rearrange the equation first with a little bit of algebra and then put the numbers into it, because it makes your working so much clearer if you do that, and it means if you make a mistake at any point, you're much more likely to get the marks for working. So we can do that. All we've got to do is to move that P over to the other side, because we want to get the V on its own, and as always things slide diagonally across, so it'll move from the top line on the left to the bottom line on the right, and we get V is equal to nRT over P. So now we've just got to put the numbers in. So it tells us, well, we know N because that's moles, so that's what we've just worked out, 0.0750. R is the gas constant, which is on your data sheet, so you just copy that one down from your data sheet, is 8.314. And T is the temperature, but you've got to be careful because it's got to be temperature in Kelvin. So you add 273 onto whatever the temperature was in degrees C. So it was 19, which means this comes out at 292 Kelvin when you add 273 on. And the pressure, again, you've got to be careful with the units. The pressure must be in pascals, and we're told it's 102 kilopascals, so that's 102,000 pascals. And if you crunch all those numbers, that comes to 0.01785. And the unit of volume, when you use the ideal gas equation, is cubic meters. Okay, so this is the one time in chemistry when we don't work in dm cubed, because that equation gives an answer in meters cubed. Now we need to give our own answer in cm cubed, because you can see that's there on the answer line, and you need to remember that there are 1,000 cm cubed in 1 dm cubed, and that there are 1,000 dm cubed in 1 meter cubed. Okay, so to convert from meters cubed to cm cubed is not just multiplying by 1,000, but it's multiplying by 1,000 and then by 1,000 again, in other words multiplying by 1,000,000. So we've got to multiply by 10 to the 6, and that means that we go 1.785 dm cubed, 1785 cm cubed is the answer. You could round that to 1790 to 3 significant figures and that would be fine, but that's the volume that you should expect.